Hello everyone, how are we doing today? Hope all of you are doing wonderful. So I'm going to show you how you are going to do the calculations for your first pre-lab assignment. Excuse me. And I hope you guys know how to access the pre-lab assignments. So when you go to your course website, you find your course. Let's say this is your General Chemistry 2 lab, and then there should be a tab. Okay, I went to the wrong tab. 2 lab, and you go to pre-lab assignments. Okay, and you click pre-lab assignments, and your pre-labs are due at the beginning of the lab period, and your post-lab report is due 1 week after the experiment date. And if you want to find out where you find the due dates and also the schedule of the labs, you can go to virtual labs. Where is the virtual labs? Over here. So if you go to this side, you will see the lab schedule, and at the top you will see pre-lab assignments are due by the beginning of the lab period, and then the post-lab worksheets are due by the next lab period. So the next week we are doing hardness of water experiment 8. Okay, always you can refer to this schedule to see which experiment you are doing, and over here you can see the YouTube videos, the virtual videos for that particular experiment. And you look up the experiment number, experiment 8, August 31st. Excuse me. And then you find your experiment 8, which is going to be your hardness of water. And if you click this YouTube link, it will show you how the experiment is being done. Okay, so you have to watch that video. And likewise, all of the experiments are listed here. Also, you find the experiment data sheet in the same virtual labs tab. So if you click this one, experiment 8 hardness of water data sheet, you will find out the data sheet with all the data that is being obtained by performing the experiment and what are the calculations that you need to do. I will show you how to do these calculations. Also, after I show you how to do your pre-lab assignment. Okay, so this is the data sheet, and this is what you need to turn in after you perform your calculations. Okay, and the way that you're going to turn in your post-lab reports is going to be like this. Excuse me. You go to your general chemistry lab, and yes, you see here the post-lab reports. You click the post-lab reports, and then the experiment 8 hardness of water, you click that, and you're going to be turning in your post-lab report sheets through these slots already made for you. Okay, so when you turn it in, you can either take a picture or you can scan it and send it as a PDF. Okay, that's how you turn in your lab reports. That's due 1 week after the experiment date, and it is the same way for all the labs. And then the pre-lab assignments, you go to this tab that it says a pre-lab assignment, and then the experiment 8 is what we're going to be doing next week. You click that, and then you can go ahead and continue. So these tests have 2 attempts, and after you turn in your first attempt, you can see which ones you got wrong, and you can try it again. And when I get your points, I will get the highest of the 2 attempts. Okay, now I'm not able to write on this one, so just to show you how to do the calculations, I have saved it in a PDF form. Let me go ahead and access that, and I will show you how to access and do the calculations. Okay, let's go over here. Okay, so these are the questions that you're going to find. Oh no, I need to download this one. Okay. So this is going to be your pre-labs look like. Now the first experiment is a titration. You guys have done titrations when you were little. That is when you were in General Chemistry 1 lecture and the lab. You have done a titration, right? Remember, we did acid-base titration using a phenolphthalein as an indicator. So the color change was in the acidic medium, phenolphthalein color was clear, and then at the end point when you add the base, when it reaches the end point, it turned to pink. Okay, so similarly we're going to be doing a titration to find out the hardness of water. So for a titration we need a burette, correct? So let's say this is your burette, and then we are going to find out the hardness of water. So the water hardness is due to the calcium ions and magnesium ions in water, basically calcium carbonate and magnesium carbonate. And titrating with EDTA, EDTA is ethylene diamine tetraacetic acid. It is a chelating agent, meaning it can bind the metal ions to this EDTA and form a complex. Okay, so what we're going to do is we're going to fill the burette with EDTA. EDTA is a clear solution, and then you're also going to use a sample, a water sample that you want to find out the hardness of water that has calcium in it. Okay, calcium ions. Calcium ion solution also clear, EDTA solution also clear. So as we titrate, we cannot find out whether we have reached the end point. So to find out the end point, we're going to be using an indicator. Indicator is called Calmagite. Calmagite is the indicator that we're going to use. So you're going to be adding few drops of the indicator. And this indicator works well at a higher pH. So you're also going to be adding a pH 10 buffer. That pH 10 buffer contains ammonia, ammonium hydroxide. So if you were to perform this reaction or the titration in a lab, you will feel it stinky because it's made up of ammonia. So you add pH 10 buffer, 5 to 10 milliliters. I believe 5 to 10 milliliters, yes. pH 10 buffer. That's all going to go to your flask. So Calmagite indicator at a higher pH, it is wine red. It's a beautiful red color. You will see this in your virtual lab. Okay, red. And then you have calcium ions. Calmagite indicator is red in color. So we're going to be adding EDTA from your burette. As we add EDTA and you have calcium ion, it's going to form a complex, calcium ions in the flask, and then the EDTA form a complex, calcium plus 2, it's a calcium EDTA complex. Okay, and the ratio is 1 to 1. 1 mole of calcium react with 1 mole of EDTA, forming a 1 to 1 complex of calcium EDTA. Now we have only a certain number of moles of calcium in our flask. When we add that certain amount of moles of EDTA from the burette, it's going to form this calcium EDTA complex. At a certain time, when all the calcium has been reacted with EDTA, there are no more calcium ions in the flask. So what happened at that point? Now we have a Calmagite indicator red in color. So as soon as there are excess EDTA or free EDTA remain in the flask, EDTA is going to form a complex with your Calmagite indicator. Okay. Now there are no more calcium ions, number of moles all reacted. You keep on adding EDTA. So now you will see the color is going to change. The wine red first going to turn into purple color because now it is telling you that you are about to reach the end point. So you keep on adding more, and then when all the calcium is been completely reacted, EDTA Calmagite complex will become blue in color. So at the end point, you are looking at the red color turning into blue. You have to wait until it has a deep sky blue color. If it is purple and if you stop it at that point, that means you have not wait until completely all the calcium ions being reacted. Okay, so then we turn into blue, you stop adding any more EDTA, and then you find out what is the volume of EDTA that used to titrate the number of moles of calcium in the flask. Okay, so and then we can find out, we know the molarity of EDTA, you know that. We can also find out the volume of EDTA that you used. So from the molarity and the volume, we can find out the number of moles of EDTA. And then since the molar ratio is 1 to 1, that's going to be the same number of calcium ions in the sample. Okay, and from that we can find out the hardness, which I will show you how to do the calculations for post-lab in separate, and but here we will focus on the pre-lab calculations. Okay, so that's basically what you're going to be doing during the titration of this particular experiment. Please watch the virtual video, so then you will see how the color changes. It's going from a beautiful wine red to a deep sky blue through a purplish color. Okay, now let's see your questions. So the first question, 0.5227 gram sample of calcium chloride dissolved in enough water to yield 250 milliliter solution. So calcium chloride is a solid. You guys have used calcium chloride in General Chemistry 1 also when we were doing limiting reactant. Remember, calcium chloride and sodium carbonate, you measured it in a balance, so it's a solid. You take a few grams and you add 250 milliliter water to make a solution. How many moles of calcium chloride are in this sample? You are given grams. Now it's asking how many moles. How do you convert grams to moles? You have done similar things many times in your General Chemistry 1. If you are given grams, how do you convert to moles? Using what? Using the molar mass of calcium chloride, right? So the molar mass of calcium chloride is also given. So you take your 0.5227 grams, right? So the molar mass units are grams per moles. So then the gram has to be in your denominator, right? So you want the moles as your final answer. So 110.98 grams per mole. So 1 mole is 110.98 grams. So 0.5227 you divide it by 110.98. When you are doing these calculations, you also need to consider your significant figures. So the rules for the significant figures, when you are dividing, you need to go by the fewest number of significant figures. So your numerator has 4 significant figures, 4 here, and your denominator has 5 significant figures. So your answer has to be in 4 significant figures. Okay, so when you divide this, you will get a number. Can you guys also do the calculation along with me? I don't want only me working these problems. I want you also to do the work. Okay, take your calculator, even in your cell phone, do this calculation with me right now. What did you get? I'm waiting. Something like that. 0.047 0.98. Is that what you got? 0.98. Okay. And how many significance did I write? Did I write 1, 2, 3, 4, 5, 6, 7? 1, 2, 3, 4, 5, 6, 7 significant figures. Is that correct? Did I write 7 significant figures? Nah. You see, the leading zeros are not considered as significant. They are just the placeholders. So I wrote the number with how many significant figures? 1, 2, 3, 4, 5 significant figures. But we want it in 4 significant figures. So what are you going to do? You're going to drop the number after the 4th one. Okay. So 1, 2, 3, 4, you're going to drop 8. So when you drop 8, 8 is greater than 5. So you add 1 to the remaining number 9. So then it would be 00471. 0.00471 when you round it. 10 in fact. And this 0 is going to be significant. Okay, because we want to keep it in 4. The zeros that comes after decimal places followed by whole numbers, they are considered significant. Okay, now you're going to write the answer in scientific notation. So when you example is given here, if your answer is 2.197 into 10 to the negative 3 moles, the way you're going to type in is like this: 2.197, you write E and then negative 3 without raising it as a power on the same line. Okay, so we can put this in the exponential notation. I believe you remember how to do the exponential notation. So you move your decimal 3 times to the right. So right now you have a very smaller number. By moving it to the right, you are making it a bigger number. So then your exponent has to be negative number. So it would be, I'm going to write it down here, 4.710, and we move it to the right 3 times, 10 to the negative 3. Okay, so the way you're going to put it in the box is going to be 4.710, and you write E, and on the same line E negative 3. That's going to be the number of moles of calcium chloride. Okay, okay. Now the question number 2. What is the molarity of calcium ion in the solution described in question 1? Remember, the volume of the solution is 250 milliliters. Now this is the number of moles we just found out. How do you calculate the molarity? Remember your molarity equation? Molarity is moles over volume in liters. So this is the number of moles. You're going to divide it by the volume. So 250.0, there are 4 significant figures. So 250, to convert it to liters, you have to divide it by 1000. That would be 2500 liters. You see, there are 4 significant figures here. The zeros after the decimal point is considered significant. So there are 4. So when you convert it or you divide it by 1000, you have to write it as 0.2500, representing there are 4 significant figures. Okay, so 4.710 into 10 to the negative 3 moles, you divide by liters, that's going to give you the molarity. Okay, can you do that calculation and tell me what you got? Don't be lazy, take your calculator please. That's going to be, what is it? What did you get? 0.01884. 884. 1, 2, 3, 4. So I have 4 significant figures right there. Okay, so you can write your answer in the box provided. I'm going to go ahead and write it down here. And there would be 0.01884. 4 significant figures, 0.01884. Oh, you can also write it as an exponent too. That's fine too. Okay, that's going to be the molarity. But don't include the units when you are turning in the pre-lab assignments online. But when you do your calculations for the post-lab, I want you to write down the units. Okay. So the next question. Suppose that 20 milliliter sample of the solution described in question 1 is withdrawn to be used for the standardization of an EDTA solution. How many moles of calcium are in this 20 milliliter aliquot? Aliquot is like a small sample. Okay, so you take 20 milliliter sample. Now you are asking what is the number of moles in this 20 milliliter aliquot. To find the moles, what do you need? Remember your equation for the molarity. Molarity is moles over volume in liters. Okay, to find the moles, what do you need? If you know the molarity, if you know the volume in liters, you can find out the number of moles. That would be molarity times the volume. Correct? So the molarity we found from question number 2, which is 0.081884 moles per liters, and you multiplied it by the volume. Volume is 20 milliliters, right? So the 20 milliliters is going to be, you have to convert it to liters, 20.00 into 10 to the negative 3, which is going to be 0.020. There are 3 decimal, okay, like this in liters. So your 20.00 milliliters right here, there are 4 significant figures. The zeros at the end are significant because it followed by a whole number. So there are 4 sig figs. I convert it to liters by dividing 1000. So I also have to keep the number of significant figures. So there are 4 significant figures right there. So liters to liters get cancelled. So when you multiply these two, you find the number of moles. Okay, that is going to be 0.003768. Have you done it in your calculator? I may be doing these calculations wrong. I can be wrong. So I want you to check the answers for yourself too. Don't go by my word. Okay, I tend to do mistakes. So you need to check to see if I'm doing these things right, or these calculations. Okay, so I got something like this, and you have to put that in your exponential notation. That would be, with the proper number of significant figures, 4 and 4, 3.768, and then exponent e negative 4. Please do the calculations and see if you are also getting the similar numbers. Just don't put my answers. I may be doing purposefully wrong. Okay, so you have to check to see if you get the correct answer. Question number 4. Okay, the balanced equation that describes the reaction of EDTA and calcium is given in the background and procedure handout. So this background and the procedure handout normally you get from the textbook, because the textbook has the information, introduction and everything. What you need to find out from that is, what is the molar ratio? What is the ratio that the EDTA and the calcium reacts? That is 1:1, which I explained at the beginning. Okay, it's a 1:1 ratio. How many moles of EDTA are required to react with 1 mole of calcium? If the ratio is calcium, 1 mole of calcium react with 1 mole of EDTA and form a complex 1:1 molar ratio. If you have 1 mole of calcium ions, how many moles of EDTA are required to react? Obviously 1:1 ratio is going to be 1. Okay, and then the next question. A 20 milliliter aliquot of the solution from question 1 was titrated with EDTA to the Kalmagite endpoint. The solution turned sky blue after 25.88 milliliters of the EDTA solution was added. Okay, remember you are doing a titration. So this is your flask and this is your burette that you have EDTA. So from the burette added 25.88 milliliters. Okay, and there are 20 milliliters of water sample in here, 20 milliliters. Okay, it's asking how many moles of EDTA were added to reach the end point. How many moles? Now, do we know the number of moles of calcium ion in a 20 milliliter sample? Have we done that calculation before? I believe we did. So there are, because since it's the molar ratio 1:1, we found, yes, question number 3, 20 milliliter sample of the solution. How many moles of calcium ion? 20 milliliters. So we know the number of moles of calcium ion in a 20 milliliter sample, right? Since the ratio is 1:1, so the number of moles of EDTA also has to be the same number, which is what we found here. So this is the number of moles of calcium ions in 20 milliliter sample. So the same amount was here. So you add EDTA. So since the molar ratio is 1 to 1, so it's going to be the same number of moles of EDTA. Okay. So from question 3, you take that number of moles and you can write it down here for your question 5. Okay. It's going to be 3.768. Same number as question 3768 exponent 4. That's the number of moles. Okay. And the next one. So now we know the number of moles of EDTA. Okay, we matched the molar ratio, found the number of moles. Now it is asking what is the molarity of the EDTA in question 5. So if you know the number of moles, this is going to be your number of moles EDTA. To find out the molarity, what do we need? We need the moles and the volume. Do we know the volume of EDTA? Yes, 25.88 milliliters. So can we find out the molarity? I believe you can, right? So your moles are going to be this number of moles, which is 3.768. See, I told you I tend to do mistakes. So if I do mistakes, you have to catch it. And I'm not responsible for my mistakes. Okay. So it's you. 3.768. That's the times OE. Negative 4 exponent 10 to the negative 4. That's going to be your moles. And you're going to divide it by the volume. So the volume going to be 25.88 milliliters. Always you need to convert it to liters. So that's going to be 0.02588 liters. So you get the answer, get the calculation and write down the answer at question 6. Okay. So can you do that calculation and tell me what you get? What's the answer? So we have 4 significant figures, 4 significant figures. We want to keep it in 4 sig figs. That would be something like, when you round it, you should be getting a number like 0.01456. 1456. Again, I am not responsible if I do wrong in this calculation. I just want to show you how to do the calculation. So you are responsible to get the correct number. Sometimes my calculator may be giving me wrong answers. So you want to make sure you also do the calculations and check to see if I am doing the right thing. And in case if you feel like I have done a mistake and you figured out that was not the correct answer, please send me an email so I can let everybody know about it. Okay. All right. And then the question 7, that's going to be the molarity. Okay. See, these are the same concepts that you guys have learned in General Chemistry 1. I do not need even to help you with any of these things. But it's okay. So question 7. A 20 milliliter sample of an unknown solution that contains calcium was titrated with EDTA solution described above. Okay. The volume of EDTA required to reach the endpoint was 13.25 milliliters. Now you are doing another titration. Now you know the molarity of the EDTA. You take a different sample that has calcium ion. You take another 20 milliliters. You titrate it with it, and then it has used 13.25 milliliters of EDTA. How many moles of EDTA were used in this titration? Again, so the process is quite same as before. So you are given the volume of EDTA and you also know the molarity of the EDTA. So we can find out the moles, right? So the moles are going to be moles are going to be molarity times the volume. So molarity is this number 0.01456 and then the volume is this number. You want to make sure that you convert it to liters and you find the number of moles. Okay, can you do that, or do you want me to show how to do that? You don't want me to. You are general chemistry too, right? Yeah, why should I? But anyway, let me do it here in case if you have trouble. 0.01456 moles per liters, and then you do 0.01325. I convert it to liters. So you multiply these two, you will find the number of moles, and then you put the answer right there. Okay, what is the answer? Well, I do have an answer. I'm going to put it right down here, but you guys do your own calculations and see if I am doing the right thing here. Okay, all right, something like that. And then the question number 8, how many moles of calcium ion are there in the unknown sample described in question 7? So we found the number of moles, EDTA. What do you think about the number of moles of calcium ion? Remember, the molar ratio is 1:1. Isn't it the same amount then? It is, right? So the number of moles of calcium ion in that 20 milliliter sample also going to be the same amount. So you can basically write down the same thing here. And then the next question. Asking what is the molarity of the calcium ions. Now that you know the number of moles, you know it was in 20 milliliter samples, you can find out the molarity, right? Quite easy and straightforward. So you take your answer, question 8, which is 1.923 10 to negative 4 moles. You divide it by the volume of the calcium sample, which is 20 into 10 to the negative 3 liters. That will give you the molarity of the calcium sample. Okay, and then the question 10, it's a conceptual one. If you do finish the titration before it completely turned blue, whether your unknown going to be too high or too low. You guys can read that and answer the question. Okay, I'm not going to help you with that. Okay, so that's how you do your pre-lab calculations, and then you turn it in on blackboard. I will explain you post-lab in a different video. Okay, bye for now.